Assalamu alaikum, grade 6. Welcome again to the physics session. Today, inshallah, we're gonna start chapter number 3. And actually, this is chapter talking about the work and machines. And that's big phenomena or a new phenomena here in physics, in classical physics especially. And the lesson 1 in this chapter that's talking about the work and power. So the title for today, work and power. That's new phenomena in physics or quantities in physics, just like the velocity, force, and acceleration. That's the new phenomena in physics. We should to know how to calculate the work and what's the meaning of power and something like that. So today the big question for this video or this is lesson number 1, how is work defined? How I can know the work meaning? What's the meaning of work? Actually, work meaning doing something or giving force for any object. So when I give any objects force, that's talking about the work, ability to give force. Question number 2, what's power? Power that's responsible for describing the rate of work in the certain time. So you can watching this video. This is by doing work when give force for this is car. And this is man that's pulling this is box and giving work and power that's work in certain time. Okay, in the beginning in this lesson we can watching this is video and describing this is man how to work and power for pulling and pushing this is weight. So number 1, this is man can pull this is weight by rope and that's doing work. So when I give force for this is weight to push it or make it move in motion, that's giving force, ability to give force to make the work. So watching again, pulling this is weight, give force and making work. So that's doing work to pull this is weight. And actually the power is the rate of work by time, by certain time. Okay, all of you now understanding the meaning of work and power. Now let's go to another step in our lesson today. So before we go into calculating and mean and knowing the formula for the work and power and the units of work and power, feats of strength. Actually, there are some people that have feats of strength, and that's for pulling or pushing objects with half weight or high weight. So, did you know this is man? This is man called Manjit Singh. Manjit Singh, that's Indian man, use his ear to drawing this double-decker bus in London for 5 meters. 5 meters only with using his ears. So you can make imagination about the doing a lot of work here with this is man. And another one called David Huxley. David Huxley, that's bolt an airplane, you can imagine, for more than 90 meters. This man landing him name in the Guinness World Records book, and this is computers have correctly worked hard. So here you listen worked. Work making work or giving force to pushing or pull something. So this is man do worked hard to get the job or to pulling. This is bus in London, double decker bus in London. You can watching this is video that give you a vision about this is man and how pulling this is bus.
I'm trying to pull this 7.5 ton bus, which is a London bus, a red one, to 10 meter with my ears. It does hurt. When the clamps goes on the ears, it's really painful. And when I take it off, it's more painful. But next morning, it will be much painful. But a couple of days later, it should be all right. Yeah, that's it. Oh.
It's an amazing feat that Manjit did here for Guinness World Records Day, and this is just part of a huge celebration that's going on all around the world, with over 200,000 people taking part in various different record attempts, from Canada to Australia to here in the UK to France. So this really is a celebration of the most amazing feats, a demonstration of which you have seen here today. Unfortunately, it won't be recognised as a Guinness World Records, but Manjit does hold several others, so thank you and well done.
So Manjit here doing a lot of work to push or pull this is pass for 5 meters. So this is the meaning of work. Work, ability to do force. If I give force any object, that meaning give him work. Empower the rate of work by certain times. So when going in the next step here in our lesson today, that's talking about the meaning of work. So how I can find it, the work. Work in the beginning, that's making something in motion. Any object can do it or give it force to make it motion in the certain distance, that's called give it work. So work here, that's meaning ability to force or giving force. Again, you do work when you apply force and to objects, and this is objects make to move in the same direction of force, and in which you applied the force that make work. And actually there is not work anymore, work without motion. You can make imagination here in this is picture and thinking about the direction of motion and the direction of force and the relation between them and the work. So here in the work we have two factors that affecting in this is quantity. The work affected by two quantities, number one force, number two distance, and the angle with the force in this is state. So this is angle and this is not important now, but I want to tell you the important now that's talking about the two factors affecting the work quantities, force and direction. So force in the same direction of the motion, and work is not or not in the direction that force applied. You can watching this as videos that's talking about the work. Work is the equal force times distance and the angle or cosine the angle with the founding the angle. Again, so when this is man that pulling this is box doing work by what? By giving the force in the same direction of the motion, but here just like in the angle of force and the same direction of motion, that's making the force. So we have three states of work. Number one, here in the picture number one, no work. Why? Because the direction of force that's not the same direction of motion. So the direction of force here, not direction of motion. And as you know, the force is the vector quantities and direction vector quantities and velocity vector quantities, acceleration vector quantities that's described by two vectors, strength and direction. So the force not here, not the like, when this is woman that's bowing the this is piano or back for piano that's up the ground. So the force up in the direction of motion in this is direction. So that not the same direction, that's called not work here. Not work here. So the work happen when the force only the same direction with the motion. The maximum work here, the state number one, when the direction of motion, the same direction of force here, just like this. So here, the work maximum amount of work happen here. When this is that pushes the piano in the ground, when this is while in the same direction of force and motion in the same direction. Some works happen here when the force and the direction of motion in the angle. So part that does not work, we can found this is part doesn't work when they found the cosine of this is angle, but this is not important to you now. And this is part of the direction of force that's work. So here you can see just like the state number 3, some works. So this is man pull, this is box in this is direction, but this is force in this. So this is not affected or not worked, and this is worked between the angle. So here the work equal force and distance in the same direction. Here you can see the example when I pulling this is box and give it force in this is direction amount of 50 Newton units and distance 5 meters. So when I making multiplying between those numbers between the force and the meters or distance, that's making the work or amount of work. Excellent. So now all of you know what's the meaning the work and how the states of work, 3 states of work. So how I can calculating the work and the formula of work and the units of work. As you know, the work is the new phenomena what we learning today, and that's describing the motion. So the amount of work you do depending into force, as you know, into factors, force and distance. So work happen when affecting an object force and making a move in the same direction or in the amount of distance. So work, so force and distance in the same direction. So here work equal force times distance. If I give you example, work equal, if I give the object force equal 5 newtons and times distance 0.5 meters. So when I'm making multiplying between those numbers, work equal 2.5 newtons meters. Okay, in the SL unit of works or the international system of units, that equal newtons time meters, newtons meters, and this is units Also, you can call it joule. Here, the new unit you can learn it today. Joule. Joule, that unit describe the work, and actually you can describing with the two names. Number one, newtons time meters, and actually unit times meters called joule. And joule that's describing the work, any work, mechanical work, electric work, heat work, any work can describing by Newton times meters and joule. And actually the definition of Newton meters or joule, or the definition of joule unit, that 1 joule equal the amount of work you can do it when the exert 1 units of force. So 1 meters when I give it force equal 1 unit. So a force to move objects 1 meter. So 1 meters, 1 unit equal joule. So I hope you understand the how calculating the work. So you can see here work equal, or W, that's the symbol of work, W equal F force times D distance. And actually you can, using the units, work joule, 1 joule equal 1 newton for force and 1 meters for distance. Joule equal newtons times meters. Excellent. I hope you understand and make imagination for the how calculating the work and the units of work. And that's new for today, a new unit for today. Actually, before that, in the last lessons, we're talking about the units of speed, velocity, acceleration, force, and gravity. Now we're talking about the units of work, joule, and that's equal 1 unit times 1 meters. And going the next step, power. What is what power, or how can calculating the power? Actually, before that, as you know, power is describing the rate of the work. So power is the rate at which work is done. So absolutely, when the work is done or happen, that's the rate of this is work called power. So the power is the amount of work done on an object in a certain amount of time. So the big units here, work and time. So power describing by two factors, work and time. And power, actually the power is the vector quantities, or a new quantities, that's vector, not standard quantities. So just like the work, power is vector quantities that's calculated by the strength and direction. Work have direction, force, and direction of the motion. So here the quantity or non-quantity here in this is lesson, power, that's describing the rate of work. We can calculating the power with the work in the certain time. So the power described by two vectors, work and time. So you can see here this is two pictures for making power. So work must be done to move the instruments. In this is car, and you can do it with yourself. So here when you do it in yourself, the kinds of work, and we can do it in this is bike, and this is twist of powerful. What's the meaning of that? That's making this is bike to do work without you. Actually, the rate of work in the same time, that's making the power. So here in this power, that's describing the work in the a lot of time. Why? Because that's making work by yourself. By here in the riding the bike, the amount of power that's going to increase. Why? Because the work happen in the fast time because they're using the bike. I hope you understand. Now we can go into how calculating the power. Actually, power calculated by dividing. Now dividing, no multiplying, dividing the amount of work done by the amount of time. So amount of work dividing by amount of time it takes to do this is work. Again, here in this video, this is man that's pushing this is box uh, in force equal 12 newtons, in the distance equal 5 meters, in the times equal 30 or 3 seconds. Actually, again, the calculating the power, dividing the amount of work and dividing in the amount of times. So here, who can tell me the amount of how I can calculating the work here? The work here equal newtons times meters or force times distance. So 12 times 5 equals 60 newtons meters or joule. So here when I make a power or calculating the power, the newtons times meters, 12 times 5 equal 60 newton meters or joule. So this is the amount of work. So here when I calculating the power, that's dividing the amount of work, 60 newton meters or 60 joule, in dividing in the times. So times here 3 seconds. So you can do it. You can multiplying first the newton in meters and calculating the amount of work. After that, dividing the numbers of work joules to the number of times seconds. So here 60. 60 times divided 3 seconds equals 20. So 20 is the amount of power here. So power is work by times, or power equal force times distance by time. So you can put it the numbers here, 12 newtons times 5 meters distance by 3 seconds time. That's equal 20. What's the unit of power now? The units of power, force, newton, and distance, meters, by time, seconds. So newton, meters, and second. And that's called, you can remember, joule. Joule times seconds, or joule by seconds. And that is called watt. Now we should know the power units. The units or SI units, International System of Units, that's called power, the joule per second, and that's called watt. And this is units also known as watt. So watt equal joule per second. And what 1 watt of power equal 1 joule of work in the 1 second. 1 joule in 1 second equal watt. And this is new unit in this is the lesson today. So work units joule and joule per second power called watt. And actually another names of watt or measuring unit of power called kilowatt. So that when measured in large units called kilowatt or horsepower. Actually, absolutely you can hear it before that in measuring the power of the fast cars by horsepower, 40 horsepower, 20 horsepower for the race car or something like that. Any car have a horsepower, and that's describing the power of the car, the amount of work in the time. And 1 kilowatt, that's equal 100, or 1000 actually, 1000 watt. And 1 horsepower equal 746 watts. You can watch this is video that's describing this is boy that's going up the stairs by doing work. So that's giving force for his leg to moving upstairs, and this is force ability to do force work. So this is boy doing huh, doing force in this direction and motion in this direction, so making work. And the power can calculate it by the rate of work. This is boy do it in the same time. So again, power, that's symbol P equal W work by T times. So P power, and that's by W, that's responsible for describing the watt. So power, watt, and power or work equal joule units and times by seconds. So joule per second, that's called watt. And we have another unit for measuring the power when large units, kilowatts, that's equal 1000 watts, and horsepower, that's equal 746 watts. Actually, this is the end of our lesson today. I hope you understand that work and power, that's new quantities in physics, in the units of this is quantities, and how calculating the work and power. Actually, any question you can send me and ask me in the WhatsApp, and please answer your worksheet or lesson quiz and send me. And please, grade 6, you focus with me and pay attention with the lesson quiz to answer it and send me in WhatsApp. All the class, grade 6. Listen to me, please be attention with me. And this is Mark. Thank you for listening, and